Good day! Welcome to our online math tutorial series of math lessons for grade 10. Tara, sabay-sabay tayong matuto at home. This is grade 10 Mathematics Quarter 1, Module 9, the Remainder Theorem and Factor Theorem. I am Marian M. Guerrero, your math teacher for today. Here are the learning objectives. In this lesson, you are expected to prove the remainder and factor theorems and find the remainder using syntactic division or the remainder theorem. Before we start, let us have this activity. Divide the polynomial function f of x is equal to x cubed minus 2x squared plus x minus 3 by x minus 2 using syntactic division. Last module, we have discussed about dividing polynomials using the syntactic division. With that, we have to get the coefficient first of the function. Then we have 1, negative 2, 1, and negative 3. Then, using the divisor x minus 2, we have to get the value of a. That is 2. Then, perform the syntactic division. First, bring down the first coefficient, which is 1. Then multiply it by the divisor 2. We have 1 times 2, which is 2. Then add it. We have negative 2 plus 2 will give us 0. Then 0 times 2 will give us 0. 1 plus 0 is 1. Multiplying it again, we have 1 times 2, which is 2. And lastly, negative 3 plus 2 will give us negative 1. Since the divisor is x minus 2, let us try to evaluate the function at x is equal to 2. With that, we have f of x will be equal to x cubed minus 2x squared plus x minus 3. When we evaluate this, we have to substitute all the values of x by 2. Then we have f of 2 will be equal to 2 cubed minus 2 times 2 squared plus 2 minus 3. Then we have 8 minus 2 times 4 plus 2 minus 3. Simplifying this, we have 8 minus 8 plus 2 minus 3. And lastly, we have now f sub 2 is equal to negative 1. Now, what can you say about the results of the two separate solutions? With this, when the function was divided by x minus 2, the remainder is negative 1. And also, when the function was evaluated at x is equal to 2, the result is also negative 1. This problem leads us to our lesson, which is all about the remainder theorem. Now, what is remainder theorem? Remainder theorem, if a polynomial p of x is divided by x minus a, then the remainder is r is equal to p of a. In the given example, when f of x is equal to x cubed minus 2x squared plus x minus 3 is divided by x minus 2, the remainder is equal to f of negative 2, which is negative 1. When a polynomial is divided by x minus a and the remainder is 0, then we can say that x minus a is a factor of the polynomial. Through the remainder theorem, we now know that the remainder is related to evaluation of the polynomial at the point x is equal to a. We are then led to the factor theorem. And now, what is a factor theorem? If p of a is equal to 0, then x minus a is a factor of p of x. Conversely, if x minus a is a factor of p of x, then p of a is equal to 0. When x cubed minus 3x squared minus 9x plus 27 is divided by x plus 3, the remainder is 0. Therefore, x plus 3 is a factor of the polynomial function. Let us now have an example. Find the remainder when x cubed plus 2x squared minus 5x plus 2 is divided by x plus 3. We can find the remainder in two methods, by synthetic division or by remainder theorem. Using the remainder theorem, then we'll have p of x, the polynomial function of x, and then we will evaluate it using the divisor x plus 3. The value of a is negative 3. Then we have p of negative 3 will be equal to negative 3 cubed plus 2 times negative 3 squared minus 5 times negative 3 plus 2. Then evaluating all the exponents, we'll be having negative 27 plus 2 times 9 minus 5 times negative 3 plus 2. Then multiplying, we have negative 27 plus 18 plus 15 plus 2. Then finally, our p of negative 3 will be equal to 8. This means that using the remainder theorem, our remainder is equal to 8. We can also check the answer using the synthetic division. Using the polynomial, get the coefficients. We have 1, 2, negative 5, and 2. Using a, we have negative 3. Then performing the synthetic division, bring down the first coefficient 1, multiply it by negative 3, we have negative 3. And then 2 plus negative 3 will give us negative 1. Negative 1 times negative 3 is 3, and negative 5 plus 3 is negative 2. Then, negative 2 times negative 3 is 6, and 2 plus 6 is equal to 8, meaning the remainder using the synthetic division is also equal to 8. Then, using the remainder theorem and synthetic division, we now get the remainder which is equal to 8. Another example, determine whether or not x plus 2 is a factor of x cubed minus 2x squared minus 5x plus 6. By definition of factor theorem, x plus 2 is a factor of x cubed minus 2x squared minus 5x plus 6 if and only if the remainder is 0. Again, we can use two methods in finding the remainder. Using the remainder theorem, let us evaluate x is equal to negative 2 in the function. Then we'll have negative 2 cubed minus 2 times negative 2 squared minus 5 times negative 2 plus 6. Evaluating all the exponents, then we'll have negative 8 plus 2 times 4 minus 5 times negative 2 plus 6. Simplifying all the multiplication, then we'll have p of negative 2 be equal to negative 8 plus 8 plus 10 plus 6. Simplifying it, we'll have p of negative 2 equal to 0, meaning the remainder is equal to 0. When we check using the synthetic division, we will also get the remainder be equal to 0. This means that using the factor theorem, we can say that if the remainder is 0, then x plus 2 is a factor of x cubed minus 2x squared minus 5x plus 6. For our last example, find k so that x plus 5 is a factor of p of x is equal to x cubed plus 5x squared minus kx minus 20. Since x plus 5 is a factor of the polynomial function, then the remainder should be equal to 0. Using the remainder theorem, we can evaluate the value of negative 5 to our function. Then we'll have negative 5 cubed plus 5 times negative 5 squared minus k times negative 5 minus 20. Again, evaluating all of the exponents, then we will have p of negative 5 is equal to negative 125 plus 125 plus 5k minus 20. Again, since the remainder is 0, then we can simplify p0 will be equal to 5k minus 20. And lastly, getting the value of k, we have 5k is equal to 20 and k is equal to 4. So we can check this using the synthetic division, wherein we have here the remainder be equal to 0, meaning k is equal to 4, to make x plus 5 a factor of x cubed plus 5x squared minus kx minus 20. Finally, let us synthesize our lesson for today. The remainder theorem: if a polynomial p of x is divided by x minus a, then the remainder is r is equal to p of a. And the factor theorem: if p of a is equal to 0, then x minus a is a factor of p of x. Conversely, if x minus a is a factor of p of x, then p of a is equal to 0. That is all for today. Thank you for listening.